A rearranging compound interest formula is pretty straightforward as long as you've been doing the normal problems pretty consistently. Okay, so let's just remember our formula: A equals P 1 plus I on K to the power KT. Okay, normally we would just find the amount at the end and maybe subtract the principal to find the interest. In this lesson, we'll be able to find the principal, we'll be able to find the rate, and be able to find the time of various problems. So to rearrange for the principal invested, we've got a scenario: how much should John invest at 5% compounding annually if he wants to have $15,000 to buy his newly born daughter a car for her 18th birthday? So I always recommend listing all of these variables down, because that's all that we'll be able to find. Okay, the amount, he wants to have $15,000 at the end. 15,000 goes here. The principal, how much should he invest? We're not sure. The interest rate is 5% as a decimal. K, how frequently it's compounding annually. So K equals 1. And the time is, well, newly born, 18 years. We're 18 years. So I'll be a good boy, write down my formula, and then substitute in all the values that I know. So A is 15,000, P, I'm not sure, 1 plus 0.05 all over 1 to the power 1 times 18. Okay, so to get P by itself, all we're really solving is an equation like this. Okay, how would I find P if I know that 10 equals P times 2? I get P by itself, dividing both sides by 2. So it's exactly the same for this problem, even though there's brackets and powers all over the place. To get P by itself, we're going to divide both sides by 1 plus 0.05 on 1 to the power of 1 times 18. 15,000 divided by 1 plus 0.05 on 1 to the power 1 times 18. And from there, we'll go to our calculator, make sure it's in math mode so we can use fractions properly. 15,000 divided by 1 plus 0.05 on 1 to the power of 1 times 18, 18. Okay, so 6232.81. And I'd write some statement for this. John needs to invest 6232.81 to have 15,000 by her birthday. Alright, so finding the principles, relatively straightforward. If you want practice, you can have a look at those exercise 8D problems. Okay, rearranging to find the interest rate, we'll do exactly the same. Okay, what interest rate compounding quarterly would be required for 1,000 to double in 2 years? Okay, ain't nothing changed but the game. Okay, do exactly the same. What things do we know? What interest rate? Don't know the interest rate. Compounding quarterly, K equals 4, would be required for a principal of 1,000 to double, so to become 2,000 in 2 years. Okay. You shouldn't have to worry about a formula sheet, because if you practice this formula enough times, you'll memorize it. Substitute in all the values that I know. 2,000 equals 1,000, 1 plus, I don't know, I to the power 4 times 2. You need to get I by itself. If I look at I, what's happening to I? It's being divided by 4, and then it's having 1 added to it, and then it's being raised to the power of 8, and then it's having 1,000 times to it. So if I want to be able to find I, I'm going to need to undo all of these steps one by one. So there's going to be 4 steps of the problem, and it's going to start with dividing by 1000. Divide both sides by 1000. 2000 divided by 1000 equals, I don't need that 1000 there anymore because it's gone, 1 plus I on 4 to the power, I'll write that as 8 to the power. Okay, from here, need to get rid of the power, so I'm going to take the 8th root. 8th root of 2000 on 1000 equals 1 plus I on 4. Okay, it's looking good. Want to get this I on 4 by itself. This plus 1 is hanging around, so I'll subtract 1 from both sides. So the 8th root of 2000 on 1000 minus 1, and then that 4 on the bottom, so I need to multiply both sides by 4. And I need to make sure I use brackets, so I'm multiplying that whole expression by 4, not just the first one. Okay, onto our calculator. So 4 times, open bracket. To do the 8th root, instead of using the power sign, we'll use shift and the power sign. So I'll put an 8 here. Inside here, 2000 on 1000. Get outside of all of this square root business, minus 1. So make sure when you type minus 1 that the square root doesn't continue across, and close the brackets. I get 0.362. Yeah, typically use at least 3 decimal places. Make sure you can do this on your calculator. If you can't, keep trying until you get that value, but don't try forever. Okay, I equals 0.362, and in this scenario the problem's not really done yet. Okay, remember I'm asking for the interest rate. I've found I, which is the interest rate, as a decimal. I need to now write it as a percentage. Okay, so I'd say the interest rate required would be 36.2% per annum. Any questions? If so, go ask someone or try some of these questions. The final one, which is probably the most difficult, is rearranging to find time. But again, I'm not going to change anything. I'm going to list all of these things I either know or I'm trying to find. Okay, let's see, how long will it take for $100 invested? So that's my principal at 5%, compounding monthly to accrue $30 interest. So I don't know the time. I know there's $30 interest, so the amount will be 100 plus 30, or $130 in the end. Okay, surprise, surprise. I'm going to write the formula and substitute in the values I know. Fancy that. Okay, here's where it gets interesting. The power is going to be 12 times t. Okay, which I'm just going to leave as 12t, 12 times t. Okay, from here, need to rearrange for that unknown power. Okay, unknown power, instantly you should be thinking use logs. Did anyone say use logs? Hopefully you did. Okay, but before I can use logs, I've got this thing that doesn't, this 100 that doesn't have the power, so I'm going to need to bring it to the other side. So get rid of that 100, and then I'm left with essentially an index statement. Okay, from here I can convert to a log statement. Okay, the base, so the power I'm trying to find is 12t. The base of my logarithm will be the base of this expression here. So 1 plus 0.05 on 12. And the number I want to get to is 130 on 100. Okay, since I'm reasonably comfortable with logs, I can then go ahead and directly find t as well. So I know t will be this whole log statement. Okay, and then from there, I'll divide everything by 12. Okay, and get a time. This will take some expert calculator usage. So in math, I use this log with different bases. Okay, 1 plus 0.05 on 12 is my base. I can use brackets there if I want. Okay, 130 on, no deal, on 100. Okay, and then this whole thing I'm going to divide by 2. Sorry, correction, divide by 12. Hopefully I don't get an error. 5.258, that'll do me. 5.258, and remember t is the time in years, so I can write directly that it's years. If I want to be even more fancy, I can try and change this into 5 years and some number of months. Okay, I've got 0.258 years. What is this in months? Well, in 1 year there's 12 months, so I should multiply this by 12. Okay, so grab my 0.258, times it by 12. So the fraction of the year that I have times the number of months in a year gives me 3.096 months. Okay, and realistically, we should be rounding probably always up to make sure that we get there. So the final statement would probably be something, if it said to the nearest month, we'd say it would take 5 years and 4 months to accrue $30 interest. Okay, always rounding up, because if you substituted in 5 years and 3 months, so if you put in here 5 years and 3 months as your time, you won't quite get 130. Okay, you'll be a little bit short. So we need to round it up to make sure that we get over the 130 mark. Okay, it's one of those scenarios where we need to round up because we're in this sort of region between 5 and 6 years at our 130, starting at 100. The graph of our balance looks something like this. I go to my 130. Okay, and coming down here somewhere. So if I was just doing years, 5 years wouldn't be good enough. I would need to round up to the 6th year. Okay, in the same way, when we start looking in the month detail, we need to be rounding there also. There's a few questions here for you to have a go at. I recommend that you try these. Okay, they'll definitely help you out and give you some practice. There will be questions on this on the exam, and you will have to probably look at it next year as well. And it's probably one of the more practical skills around, so give it a good shake of the sauce bottle, and we'll have a look tomorrow.